Little pre-calc, Wednesday, 5/3/17. We are going to be looking at more fun functions. So we're going to look at the 8 parent functions. They're called parent functions. They're kind of the basic ones from which all the others, or so many of the others, come from. So there are 8 of them, so we'll start going through them. The first one is called the constant function. The constant function is f of x. You can think of it as y, but since we're studying functions, I'm going to use the functional notation. It's read f of x equals some constant. And I'm going to graph for us f of x equals 3, for example. So I'm going to graph it. 1, 2, 3. It is a horizontal line crossing at y equals 3. So it depends what c is. It could be -2, where it would cross down here. It could be 0. So this is an example of the constant function. The second one is going to be called the identity function. And it's called that because when you do a Sissy chart, the x and the y are identical, identity functions. So if we put in x as 0, y is 0, x is 1, y is 1, x is -2, y is -2. It is a straight line, so those 3 points are enough. So it cuts exactly through the middle of the third and first quadrant, and that's called the identity function. Third is the squaring function. You should know all of these, but I am presenting them by way of review. F of x equals x squared. So the most basic parabola, if you don't know its shape, you can do a Sissy chart when no one's looking. When x is 0, y is 0 squared. When x is 1, y is 1 squared. When x is 2, y is 2 squared. When x is -1, we put the -1 in and square it, you also get 1. And when x is 2, we get -2, we get +4. So 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. And it is a rounded curve like that, and it's called the squaring function. It is a smiler, smiling at you. All right, the next one, these don't have to be memorized in any order. The cubic function, y or f of x equals x cubed. And I'd like you to know these by heart without a Sissy chart, but as we're reviewing, I will develop them. 0 for x, 0 for y, and 0 in for x gives us a y of 0. 1 cubed gives us a y of, I'm just going to indicate that this can be thought of as y, and then it's a little more clear. Y, when you put a 1 for x, you get a y of 1. When you put an x of 2, you get 2 cubed, which is 2 times 2 times 2. Let's do a couple negatives. -1 cubed is -1, and -2 cubed is -8. 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. And they connect in a curve like this. All right, so that's the cubic function. All right, halfway through our parent functions. Number 5 is the square root function. Some values that we know for the square roots are 0, 1, 4, and 9. 0, the square root of 0. Let me give you the function. And we can write that as f of x. So 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and the square root of 9 is 3. 0, 0, 1, 1, 4, 2, 9, 3. So it starts abruptly here. We cannot have the square root of a negative number. So therefore it starts abruptly at 1 and there we go. It's rising but slowly. All right, the reciprocal function f of x equals 1 over x. We can think of that as y. So put in some values for that, like 0, 1, 2, 1/2, 1/3. And let's do some negative ones. Negative 1, negative 2, negative 1/2, negative 1/3. See if that gives us an idea of what's happening. When we put 1 over 0, we get undefined, so we cannot have a value there. When we put 1 in for x, we get 1. 2, we get 1/2. 1/2 gives us 2. Let me graph these as I go. So 0 has undefined, 1, 1. 2 over 1/2 up. 1/2 over 2 up. 1/3 over 3, because the reciprocal of 1/3 is 3. So, and if I snuck a 3 in there, I get a 1/3. So this side looks like this. And we have negative 1, negative 1. Negative 2 is negative 1/2. Negative 3 would be 1/3. Negative 1/2 is negative 2. And negative 1/3 is negative 3. So we have the mirror image over here. All right, that's a reciprocal function. These are actually asymptotes. The function will get closer and closer to the x and y axis, but never touch them. So we call them asymptotes. We put them in with dotted lines, dashed lines. All right. The next one is number 7, the absolute value function. And it looks like f of x or y equals the absolute value of x. So So I can put in 0, 1, 2, -1, -2, and we'll get a fine look at that. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of -1 is 1. The absolute value of -2 is 2. So graphing these, 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. And this is comes to a sharp point like that. All right, and last one is the one you may not have met. I'm not sure if you have. It's called the greatest integer function. The greatest integer function. It has a symbol that looks like this. It's sort of like a bracket with two lines in it on each side. It's read the greatest integer function, and this means whatever value I put in for x, I want the greatest integer less than or equal to x. And recall the integers in your thought cloud. Grab yours, Maggie. Thank you. -3, -2, -1, 0, 1, 2, 3, etc. They go forever in the negative direction and in the positive direction, but they do not include fractions. All right, so therefore we are going to graph that one. It's a rather strange one. So we'll take our time and Sissy chart this one to death. So x and y. So I'm going to do 0, 1/3, 1/2, 7/8, and 1 for my first segment. So when I put a 0 into this function, it says, what is the greatest integer less than or equal to 0? Well, 0 is an integer, and it's equal to 0, so we're going to have 0. Now when I put 1, what does that say? 1/3 in, then I have the greatest integer less than or equal to 1/3. So the integer less than 1/3 is 0. So if this is 1/3, we've got 0 again. The greatest integer less than or equal to 1/2, 0. Yep, I got a phone call. I'm going to check it out, so I'll be right back.